It's 15:45, so welcome everyone. There's still people, some dropping in, so please come join in. Welcome to our talk. My name is Kenny and this is Bruno.
Hello everyone. I just come from Paris. Sorry for my accent.
So we're going to talk a bit about deep dive into model-driven design. And to do that, we need to give a problem. So we're going to run through a problem with you. We're going to do some modeling. We're going to do some live coding together. And the problem today is, as you can see in the back, it's a theater. And I must tell you and warn you, this is a theater in Paris. So this is not a theater here in the Netherlands. Theaters in Paris get very busy, right? People often go to. And there's a lot of spots that get open. So our problem is, how can we make sure that these theaters get filled in, right? Right now, our business has sort of like a reservation system like you would do in a cinema, but that doesn't match with the theater concept. So that would be our problem that we're going to work with. Yeah? And we're going to run through you. And the way we approach this is using a thing called domain-driven design. So who's familiar with domain-driven design?
Wow.
So that's great. So this talk won't be specific about domain-driven design, but we're going to show you techniques from domain-driven design, and especially part 3 of the book. Yeah, so we're going to run you through. So domain-driven design, for the people that don't know it, it's a discipline rooted in the belief that creating good software system cannot be done without a deep understanding of the business problem, right? So it's the business problem that drives our software design and which drives our solution. So that's actually domain-driven design. The rest that we use are all patterns, principles, and tools. Yeah? And one of these patterns inside the book is the bounded context pattern, which is one that Eric Evans, it's one of the newer and one of the most familiar pattern, but it's also the most misunderstood pattern. The bounded context pattern, in essence, is that we have a model to solve a specific problem. And Eric Evans refers to the Mercator map, which is the map we all know, where Africa and Greenland are the same size, which it's not. But that map is there to solve traveling by the ocean. Yeah? And that's what we mean with the bounded context. We create a model to solve one specific problem, and it has its own ubiquitous language. Yeah? So when you're solving that problem, you know what words mean. Same if I go to Paris, they speak Parisian, not French, I learned today. But they speak a different language. That's the same with the bounded context, right? It's not that your whole organization speaks the same language. Each of these bounded contexts has their specific language. That's a one-on-one in bounded context pattern. And we can use a canvas, which is called the bounded context canvas. This is made by the DDD crew to actually capture that model. And we can give it a name. So for our problem of the theater, we're creating a new bounded context called seating place suggestions, which is, the purpose is by analyzing seat quality, viewer preference, and theater layout, it suggests optimal seating choices. So it's there to solve the problem of filling the theater, but also make sure people can pick their spots that they want. Yeah? That's the problem that we're solving in this bounded context. There's more to it. You can read it more online, but the basic thing that I want to show you, 2 key things here is we have the ubiquitous, we have the ubiquitous language here, where you can see there's an auditorium seating, there's a pricing category. I'm capturing the language that's being used. And especially important are these business rules. These are like, well, we only need to suggest available places. From these language and from these business decisions, we can create an object model that we're going to work with today in our code. And this comes from Rebecca Wirfs-Brock's book, Object Design. Who knows CRC card modeling? Wow, great. At least a few people. This is a very nice tool. Early 2000s, late 90s, this was created. It sort of looks like UML, it's not. It's about responsibilities, what it knows, what it does. it's about the name, and it's about the collaborators. It's really about what object has which purpose. So we can take, for instance, the business rules we just have, the nouns we just have, and that's what domain-driven design tries to teach us, and we can create this object model, and this object model, if you look at it, who says, well, for a theater suggestion system, this looks okay, right? We have an auditorium seating that has rows and that has seating place. Sound familiar? Well, you're sitting in rows as well. You're having seating places, right? Yeah? So that's object modeling. But the thing is, and that's what our talk is about today, this is how we usually, or maybe you do it slightly different. That's okay as well. Maybe you use UML, fine. But this is usually the initial software model, one that's grounded in the early understandings of our problems, right? Does that model over time fail to accurately reflect the main concerns of a domain expert? So looking at this model, it can also solve the cinema reservation domain, right? If I look at it, it's rather, well, we have different words for it, but it's very initial. And what we usually don't do is through coding, create a deeper model. That's what we are going to talk about today. So, one thing that we want to challenge the model with at some point, we say, well, we have this nice clear example here of about how a theater would work. And we have a new insight coming in, right? We've been writing already some code to solve this model, and we're going to show you the code later. And all of a sudden, our PO comes in, and the PO says, you know what? I have a good idea. We have 3 categories here, category 1, category 2, category 3. These are pricing categories. And we figured out, right, if we suggest only the categories, that the things on the boundaries, the seating place on the boundaries, will usually stay open. So maybe it's a good idea to also propose mixed categories. Yeah? Who's ever had that situation where, well, everything is clear, let's build, and all of a sudden someone comes barking in and say, hey, I have a new idea, and then it totally breaks your model. Who has that? Yeah. And then it becomes a bit quirky in the model, and that's what we're going to show you. So the mixed model means one thing, each category, we have 3 suggestions per category, and the suggestions cannot repeat the same suggestion. So if I say, I suggest A3, and I need to suggest another seat in the same request, I cannot suggest A3 to the same person again, it will be A4. But once we suggest mix, it's possible again. Is that clear? So within mixed, we can suggest the same seats again as we did in the previous categories. Shall we show a bit of code? So we implemented it, we started to implement it. We like to use TDD for that.
Who use C#? Who use Java? Okay. Sorry for Java, it should be C# for today. But it's not so different, actually, especially with the latest version of Java. So
I write in Java, by the way. I also made a Java version out of this.
So before to deep dive in the new feature mixed category, we should introduce the acceptance test. So the first one is very obvious. The theater is totally full. It's very small. There is no room for a new seat. So when we ask to a party of 1, we obtain an error, a message as a suggestion not available. It's
Everyone
clear.
able to read this?
Okay.
In the back as well, it's big enough?
I can increase a little.
Can increase a bit?
Yeah.
For the non-C# readers, still readable? Hopefully. So that's also the good thing about a proper
The
acceptance.
check that is an assertion inspired by the Java assertion, AssertG, actually. So the second one, there is only one room possible. It's A3. So we ask for a show ID. It's a specific theater. And the party is 1. And we ask with this one, seating place recommender. and we ask with the verb, make suggestion. And he returned back only one answer, E3. That's exactly which one we want. And finally, the last one is about the mixed category. And we just start to implement it. It's not finished. We notice there is something goes wrong. But just to introduce you, it's very similar with the previous test. We call it this one, but in this case, we have several propositions per category. The first category, the second, the third, and the mix. And you can notice the mixed, sorry, yeah, thank you. The mixed,
Hopefully, nope.
no, sorry. The mix, I repeat again, no. The mix proposed seat already proposed in other category. For example, A1 is there, E2 is there, and E3 is there, okay? So if I run the test, or we could...
Yeah,
run the test.
Run the
Okay,
test,
okay.
and you can see what can go wrong.
Yeah, okay, I run.
So we just introduced the new concept, right? PO came in, let's do something. First thing we do is implement it, have the test, and we think, it worked, but...
You see,
there's a problem.
he returned back this one, and I wait for this one. I return back to the slide. Not this one. Yeah, you notice on this one, we want this one. We have no affinity about category, actually.
Yeah, so we wanted A1, A2, A3, and we got these three. Anyone from this example already?
I return back to the code just to see the error. So finally, the code doesn't work. There is a bug inside, and the goal is to find why we have a bug.
Anyone from this example can already think about what would be the problem here?
No.
So if you go back to the slides.
I give you some tips about the name of the seat proposed, suggest. You notice some seats are already suggested. And finally, the answer is composed of seats never suggested.
So it's not resuggesting the same seat.
Exactly.
Yes, exactly.
And why don't do that? That's a question for you. Why is propose other seats that are expected?
Yeah, in the back? Yes. Exactly. So we have a mutability problem here.
Yeah.
So maybe we can try to fix that.
Okay.
Yeah. So let's quickly go through the code and let's see. And there's a thing with mutability within domain-driven design, and we're going to explain the concept later. There's a problem with mutability that it makes sure that we're further away from our domain concepts, and we're going to show you why.
So I need to dig inside this function, and we see we call several times the treatment for each category, but the problem is with the mixed category. So I dig it inside, and inside, yeah, to be sure everyone see everything. We prepare the context each time for the good one. So I move on the right. We have the request. The request contains the party, the number of people, and the category. Okay, and we look if the suggestion match the expectation. And finally, we do something very strange. We ask to allocate a new auditorium seating, that's the topology of the auditorium, to obtain a new one with the seating allocated. So it means with this code, normally, there is no problem. It should give me a new one each time. So normally, the bug does not exist. So the problem should come from there.
Yeah, and it's very simple why we allocate, because within the same category, we cannot resuggest the same thing. So if we have a suggestion, we allocate it in our model, and then we try to find a new suggestion for that category. But for some reason, it pertains over categories as well.
So you see, allocate, return, as we saw before, auditorium seating. So we make a kind of a copy of an existing auditorium with a new seat allocated, that's the algorithm there, to obtain a new auditorium. So it's perfect. But here, there is a problem, because we don't return back a new auditorium. We return the existing. So it's not a good one. So the good answer should be, I remove this one. I do new auditorium seating. No, not this one. I copy paste all the lines, sorry. And I put a parenthesis there, and I remove this one. And I remove this one too. So if I run the test.
So one thing what we did here is we made the auditorium seating immutable now, right? So it's not an entity anymore, it's not mutable anymore. And when you go back to...
Yeah, I return back, because we apply a pattern, and we should talk about this pattern when we return back the same type of a name. And the name, I can write it, is closure of, operation.
Who's familiar with this pattern?
It comes from supple design.
Yeah. If you can go back to the Miro board.
Yeah.
So there's this whole thing in part 3 of the book by Eric Evans, and he talks about supple design. And supple design reveals that deep underlying model that makes it potential clear. And we use the supple design to make sure we're not getting into these frictions, because one thing, your code is not the domain model. The domain model is what you speak and what you create with your stakeholders, and your code is a reflection. What will happen is that over time, you have conversations with your stakeholders, you get a deeper understanding, but your code is still at the same spot. Then we need to start to modify our code. And if this is just a small example, which is already a small code base, which already has a bug. But if you have complex code bases, and you start introducing things like mutability, and if you do it correctly, it can help you. But these patterns will help you stay closer to the concepts in your domain model and makes your code more easily adjustable to changes in your model. And here's closure of operation is one, but you also have the thing called value object. From a domain-driven design perspective, we rather work with value objects, which are immutable, than entities that are mutable. Mutability for us is very hard, because somewhere underneath our code, something changes that we needed to really debug in to see, oh, but over here, we mutate that. Can you really explain that to your stakeholders? Probably not. So this will help you stay closer to the concept of your domain model. And this will help you then to go to the second part, which is what we call deep modeling in domain-driven design. So our next part would be about introducing this new concept called suggest placing option close to the center of the row. So if I look at this, I see less people sitting over at the sides, more people sitting in the front, which is our new suggestion, right? Makes sense? So if people go to the theater, who wants to stay closer in the middle than to the sides in the theater? Yeah. So not everyone, but most of our people want. So, you know, we need to make choices. So we make this choice to go suggest place this option close to the center of the row. What you want to do at this point is start modeling with your stakeholders. What does that actually mean? So we have now a party of 2. One thing that we like to do in domain-driven design is clear examples, right? So here is an example of two types of theaters. One is with equal amounts of seats in a row, and one is with unequal amounts of seats in a row. Let's say I have a party of 2, and then let's ask you, if I get number 1, so this top one, if I give a suggestion for 2 seats, which suggestion needs to be first? So I hear some people say 5, 6, 3, 4. Would that be the center of the row for you? Center-ish, yeah. Well, that's good. So then I want to understand why 3, 4. Anyone else? So I have 5, 6. That seems to be the center of the row. But when I look at the second example, what would you say? I hear 5, 6, and some people say 5, 7. Well, you know, it's good that I now already start modeling this with my stakeholders because we can make a decision. What would be the center of the row here? Right? So this is a concept in our domain now that I can just by giving a clear example tell you, okay, we have a middle of the row. So we could say, sorry for the people on the second part, but I'm going to remove that. And we're going to make a clear distinction that this is the middle of the row here, and this is the middle of the row there. But I can also say, let's say, well, which one can we remove? So let's say this was already reserved.
Yeah.
So 5. What should be then the middle of the row? Which one to suggest? 6, 7, exactly.
Yeah.
So this is very important for us when we start to model, is to keep continuously do this with your stakeholders, right? Just draw something up. Well, just draw something up. In this case, we have a very clear example. And from that, we want to say, what's middle of the row? So who can tell me what's the middle of the row? How would you define that?
Yeah.
Yeah, so I can take the row itself, divided by 2,
2.
and then minus 1.
Yeah.
If it's even, if it's uneven, yeah? Yeah?
Yeah.
Okay, so, and when we look back to our model itself here, where should we introduce this middle of the row concept? Or where we should introduce this new function in our model? In the row.
In a row.
Yeah? Yeah? Anyone else?
Yeah.
So the thing is, at this point, we have a model. And for you, a software model is always an abstraction of reality, right? Just like the Mercator map. Things, you create a model to solve a specific problem. The thing is, when we get new insights, we're not sure where it might fit. We think it's row, but are we really sure that that's the best place? So what we're going to do is we're going to go back to our code.
Yeah.
And one thing that we want to do, instead of building it into row, we're going to build it inside our unit test. So we're going to use a unit test to start implementing this. And we want to use as least as possible of our current model to solve this. And there's a very particular reason we do that. It's because we don't want to be biased by our model. If we do that, the model stays always the same. And over time, it becomes very ambiguous. What does row does? What does a row do? What's the purpose of a row? Because now the row is to know the state of what seats are in. We're going to do the center of the row, and over time, we're going to give it a lot of responsibilities. People who know solid might think, separation of concern? Yeah. Is that something you see over time happening in your code? Objects become too big over time. Yeah. So let's see an example. Here's the row shift
we
test.
prepare a test with 10 seats, and you can see several categories. And we can see some are already reserved. This one, for example, and this one. And we assert and we consider A5, A6 as a good answer because the party size is 2. We ask for 2 people. But there is something very important in model-driven design. Eric said we should start outside the current version. You start with a prototype. It means you design without biases of the current design. So it means you design from a clean situation. That's very important.
Who's using test-driven development or anything here? Consent? What I usually see is why we can't do it is because we don't have the understanding of the domain enough. These clear examples, right? These will help you design your TDD, and it makes it a lot, as we show you here, right? We can create a very concrete example from what we just did. So and that's the key to doing proper TDD.
So nothing is returned because the function is empty. So the first thing we talk is about the middle of the row. So just to clarify, I just add a comment. I kind of encourage you, when you do that, make some comment, not for all the time, but just when you're thinking. So I would like to divide into the list of the row, and I would like to write the definition in code. You explained it a few seconds ago. So middle of the row is more about the row, sitting place, and count. Okay? And you said we divide by 2, and I'm aligned with that. So I introduce a name. I call it middle of the row. Okay? And now I need to compute what I call the left part and the right part, the right side. I love divide and conquer. I consider it generally a good way. So I write row, okay, sitting place, perfect. And now I would like to take only middle of the row. So in Java, take is how we spread Kenny. Do you remember to do take in Java?
Not from the top of my head. Who knows? Take the left one. I know it's in a stream.
No, but, I take middle of the row. He says that's a good one. And now the select in C# is a collect in Java. I should do, it's a double arrow in C#, and I have a snippet to fill all the thing. But I would like to add something about this. You see the value there? 2, 1, 0. It's what? It's a distance. The distance from the middle. Okay? So I need to compute that. So to compute that from the middle, so I have the sitting place. I have a field called number. I would like to do minus. What do you think? It's a minus middle of the row, or it's opposite? It's a middle of the row, minus. I don't see clearly the minus on my board. Yes, it's there. It's correct for you to compute the distance? If my middle of the row is 5, and my city place is, for example, A3, so I get 2, and it's correct, it's positive. So I have a squiggy because I introduce a new parameter, and the ID asks me create a new parameter. So I create a new parameter.
Are you still able to follow what we're trying to do? So we're trying to take the left side, we're trying to compute per seat the distance. Now you might think, I have a better idea. Great, do so. There's many ways to solve this problem, right? It's not about the actual solution, how we solve it, but we're going to get to the goals in, because we introduced the distance to the middle of the row now, right? And we're going to work with that. So we do now, and here it becomes a bit because we're changing our seating place now.
Yeah, and I need to fix that. And I use an ugly way to fix that. I made a default parameter as -1. It's not very correct.
Who likes this?
It fixed my problem.
Who's ever seen that we get into this point where we're like, to solve it, I need to, but who's had this before? Yeah.
So I need to introduce a variable.
Stick with that thought, because we don't like this either, but let's first solve the problem, right? Divide and conquer. Let's first solve it.
Okay, that's done for the left side. I do the same for middle of the row, select, sitting
Skip is taking the other side.
place. I do the same to fill sitting place. Yeah, and I do the compute. I suppose it's obvious. I opposite the parameter, sitting place minus middle of the row.
And we're now working with the even row first, right?
So number.
Again, divide and conquer. First take one example, fix it, and then introduce the next one.
And to be sure I obtain the good answer, I can say sitting. I have no value. I need to introduce a variable. Yeah, sitting place with distance. This distance. Distance from. I use which name before? I don't see. With distance, right, yes.
From right side.
From the right side, yeah. From the right side. Okay. So now I can do sitting place left side, collect, concat, sitting place.
You were using Java.
Right side. Okay. But I'm not totally sure about my computation, so I would like to extract that in a specific method. I call it make sitting place with distance.
And again, over time, you might change the naming. If you do pairing, or you do this with your team, you come up with better names, right?
So I make a new assertion there. It's check that make sitting distance, I put the row, and I select, collect, if you will, sitting place, and I would like to project distance with middle of the row. And this one should contain exactly 4, 3, 2,
Who
1,
thinks this
0,
is gonna work?
0, 1, 2, 3, 4. Right?
Who thinks this works? Who thinks it doesn't work? And some people are not sure.
Sure. So I run the test to see. No, it doesn't work. Why? You have the answer?
The middle is only one number, so how can two
Yeah, it's correct. So the way to divide by 2 is not totally equivalent for the left side and the right side about the seat number. So we need to pad with a number to obtain the good one. So I return back to the code. So I think it was the
Right side.
See, is there, yeah. So I need to, do something like that. +1 to be sure to obtain the good one. So I run only this one. I know. Yes, it's correct. We pass the first assertion. Now we have a problem with the last one. So I need to fix the last one. So the last one, we need to order by, we sort, sitting place with distance. No. Sitting place with distance. And we sort by distance, okay. And now I need to do where, sitting place, sitting place. Yes, sitting place.
I recently let him switch to rider, so...
yeah, sitting place. And sitting place, I need to select seat available, sure. And the last one, sitting place. And I need to do sitting place, yes. And match to the category, pricing category. And if I run the test, it's correct.
So can you go back to the Miro board?
Yeah, sure.
So this shows you a bit of how we prototyped outside the code, right? So we used the model, but there's a quirkiness here that you already saw, right? So let's give you a bit about that. So the distance from the middle of the row is now in seating place, which when you create that seating place, you need to give it a number, -1. Try explaining that to your stakeholders, that you need to do that? Well, I can explain it, but it sounds weird, right? I have a seating place with -1 from the distance. What? So what happens is these things, just by doing it in your test, can give you the opportunity to improve and create a deeper model and make these more into a seating place with distance. So there's concepts now popping up, and the important part is here, we usually solve this as engineers, right? We might be able to solve this and create a new object. Who would do that? Who would create a new object here? The thing is, if we don't do this, our code starts to go further away from our domain model that we talk with our stakeholders. And that's very dangerous, because every time you're in a conversation with them, you need to translate in your head, oh wait, yeah, that seating place now has a distance. And just by creating a new value object out of it, in a deeper model, and also explaining this to your stakeholders, to do this, we need to create a new object that we call seating place with a distance. You need to bring that back in that communication, because you stay aligned now with the mind and with the model of your domain experts, right? With the model of your stakeholders. If you don't do that, your code will drift further away, and your code will become harder to change over time. Who has that problem that you're over time creating models, and then over time at some point you're like, okay, if we need to do that, and you start to compute in your model, in your mind, oh, then I need to do this, and you start to translate that. Who has that problem? And that's not what we want as when we do domain-driven design, right? We want our code to be based on the domain model, and the domain model is what we speak with our stakeholders.
Here we go.
Yeah, and well, not sure if we go deeper.
Okay.
because we're almost finished, out of time. You want to show?
How to fix it?
Oh yeah. Go
Okay.
quickly to. Let's quickly fix
Okay.
fix this and introduce this seating place with distance.
Yeah. So to do that, the first thing we have to do is to change the name. So cities place with distance. Okay, so new name. We don't want all the information. We keep only sitting place and the computation of the distance. We create a record. I know in Java there is a record too. Okay, perfect.
Java 14, 17.
Yeah, something like that. It's not a good name here. It's a distance from the middle of the row. Okay. I do the same with the second one. So I do with distance. Okay. I remove the parameter I don't need, so I do that. Okay. The type is not a good one now, so I need to change the signature. So it's just with distance. Okay. There is consequences about that, so I need to fix this also. So I introduce another collect or select in C#. So sitting place with distance. Okay, sitting place with distance. No, this one is a sitting place. Yeah. Now I obtain the collection I want. I need to return back to the sitting place. Sitting place, this one is not necessary. All right, so I remove this parameter. Okay.
So now we remove the quirkiness in our code, right?
And
Now it's become a clear concept.
yeah, and now I would like to run all the tests.
So
Yeah.
it might feel that we do a lot, right? Because we can solve it maybe easier in our code. The thing is, the most important thing is that conversation you keep having, and if you can go back to the
To the mirror.
to the mirror, what we want in deep modeling is these concepts that we create in our code, you want to put back into the domain model, right? Most people that do domain-driven design say, well, the business has their language, we need to use that language, but we, as designers and coders, also introduce concept in the domain language. It's a feedback loop. You need to continuously start doing this with your stakeholders, at least your PO, so that you're aware of these concepts, they are aware of these concepts, and it needs to return. So what we did here with deep modeling is a few of the things that Eric talks about, is start implementation in your unit test, because that can pop up these quirkiness, pop up new concepts, right? Make your domain concepts then explicit, and your code should be explainable on a whiteboard with stakeholders. That's actually your domain model. This is the whirlpool that you go through, right? Because we started here with the model, we went to code probe, but we quickly went to that whirlpool, going back, here's a new concept, seating place with distance. Go back to your stakeholders. Does that make sense to you if I explain seating with distance? And they might say, not really. Then we have a good conversation. And we might have new breakthroughs. But the only thing that you can do this is by using that thing that Eric in part 3 calls the supple design. Because the vital details about the design is captured in the code. A well-written implementation should be transparent, revealing the model underlying it, right? We added seating place with distance. So when I show the code, I can see something with distance. I can even extract the center of the row as a concept, as an object in my code, right? Now it actually starts speaking to me if I look at the code. And the things that are in the code as objects, they refer back to in my conversation with the stakeholders. That thing, there's a lot of waste happening in that conversation with your stakeholders, a lot of misunderstanding. That's what domain-driven design tries to tackle. And it doesn't stop once you design it. It also continues while coding. And that's the important message that we have here. So supple design enables deep modeling, but deep modeling enables supple design again as well. So this will give you breakthroughs in product development, and I think we're almost finished. Because now we stay closer to the concept of a domain model, we can introduce new concepts, we can create breakthroughs through our code as well, but everything starts being closer and start being... You only do this, by the way, if your code is complex, right? If it's a simple CRUD thing, skip the domain-driven design, please, right? It's not a silver bullet. Only do this when your examples are very complex. And this is what Eric Evan talks about in chapter 10 of the book, right? We need to live in the domain, we need to keep looking at things in a different way and maintain an unbroken dialogue with our domain experts. So that means we also need to put concept back in that statement. If you want to know more, we're giving a deep dive into this as a workshop online. And thank you very much. My name is Kenny Baas, this is Bruno Boucard. And thank you very much.
Thank you.